L1 stands for Lagrange point or liberation points, which are the points of equilibrium for small mass objects under the gravitational influence of two massive orbiting bodies. At Lagrange points, the gravitational pull of two large masses equals the centripetal force required for a small object to move along with them. This is useful in reducing the fuel consumption of the satellite to stay in position. For any combination of two orbital bodies, there are 5 such Lagrange points in the Earth's Sun system which are named from L1 to L5. The unstable points L1, L2 and L3 lie on the line connecting the two masses, the Sun and the Earth. 2. The stable points L4 and L5 form the third vertex of the two equilateral triangles that have the large masses at their vertices. The L1 point lies on the line defined between the two large masses M1 and M2. It is the point where the gravitational attraction of M2 and that of M1 combine to produce an equilibrium. At the L1 point, the object's orbital period becomes exactly equal to Earth's orbital period. L1 is about 1.5 million kilometers, or 0.01 hour. The L2 point lies on the line through the two large masses beyond the smaller of the two. Here, the combined gravitational forces of the two large masses balance the centrifugal force on a body at L2. An example of a spacecraft at L2 is the James Webb Space Telescope, designed to operate near the Earth, Sun L2. The L3 point lies on the line defined by the two large masses, beyond the larger of the two. Within the Sun-Earth system, the L3 point exists on the opposite side of the Sun, a little outside Earth's orbit and slightly farther from the center of the Sun than Earth. This placement occurs because the Sun is also affected by Earth's gravity and orbits around the two bodies. The L4 and L5 points lie at the third vertices of the two equilateral triangles in the plane of orbit whose common base is the line between the centers of the two masses, such that the point lies 60 degrees ahead of L4 or behind L5, the smaller mass with regard to its orbit around the larger mass. Here are some reasons why the L1 Lagrange point was chosen for Aditya L1 mission. 1. Uninterrupted solar observation. At this location, the spacecraft remains in line with the Sun and Earth. It is possible to monitor continuously without obstructing the Sun's view by Earth. Stable orbital configuration. Lagrange points are positions of gravitational equilibrium in a three-body system. The L1 point is stable for a satellite or spacecraft, which means it requires minimal fuel and orbital adjustments to maintain its position relative to Earth and the Sun. Space weather monitoring. The continuous monitoring of the Sun from the L1 Lagrange point is essential for space weather prediction. Solar activities, such as coronal mass ejections and solar flares, which can influence the communication systems and satellites. Observations from the L1 point enhance our ability to forecast and mitigate potential space weather-related impacts.